Hello everyone. Do you hear me clearly?
Yes, we hear you clearly.
Good.
So I will open today's session. Thank you so much, Dr. Maher, for joining us. Good
Okay.
afternoon, everyone. All of dearest participants, may I have your attention, please? We have around 160 participants, and I think it's still adding up. So in total, we will have more than 200, hopefully. So please, you can enjoy this guest lecture. It's about to begin. Thank you very much for preparing yourself for this Saturday to join our international guest lecture. This is held by Information System Department, Institut Teknologi 10 November. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. It gives me a really great pleasure to welcome all of you to this international guest lecture. Uh, the topic is data science, what and how to implement in daily life. My name is Raras Jasnurita. I'm the moderator for today's lecture. I'm very pleased to see some students here that joining. And yeah, I welcome all of you to this event. We have international participants, so we have from the International Undergraduate Program as well to join. We have students from Indonesia, Malaysia, and Saudi Arabia. So from ITS, Information System Department, uh, please raise your hands who are from the Data and Diagnostic Analytics. You can raise your hand, please. Yeah, so I believe around 40 students came from the Data and Diagnostic Analytics. And then some students are from the predictive modeling analytics and also the prescriptive modeling analytics. Some also from the soft computing as well. Um, may I have the opening slide, Adit? Could you help?
Hey, Miss, wait a minute.
Sorry, so do we already have this opening slide? Yeah. It's very exciting that the number of participants still add up. Now is 176. Yeah, so um, it's really interesting. The end of the weeks, we have this guest lecture on Saturday. Can I have the next slide, please? So I would like to introduce some of the participants' backgrounds that is come from these data analytics steps. So for each steps, we have class in our department. So we have this data and diagnostic analytics for the descriptive and diagnostic analytics process. And we also have predictive modeling analytics for the predictive process in the data. And the prescriptive modeling analytics. We also have a class from the soft computing as well to join. Next. So as we know, the data science is crucial, right? So because we turn a vast amount of raw data into an actionable insights. So we driving better business decisions, we optimizing operations, and we also powering the advanced technologies like AI. So this hopefully will help organizations to innovate and also stay competitive in the data-driven world. So in today's lecture, we will get a closer look into the implementation of data science in daily life. I would like to introduce to our speaker, Dr. Maher Mohammed Aseeri. Dr. Maher has been the faculty member for Applied College at Najran University. Previously, he is a faculty member at the College of IT from the University of Jeddah. So he received his PhD degree from the University of Technology, Sydney, his Master and Bachelor of Information Technology from Malaysia, which are from University of Technology Malaysia and Tenaga Nasional University. Dr. Maher has received many recognition during his professional career. So among of them are as the member of Saudi Association of Information Systems, the reviewer at the Middle East and North Africa Conference for Information Systems, as well the Best Student Awards and also the Best Thesis Awards. Next, so before the presentation begin, I would like to tell how this lecture will go. So we have this timeline. So we have Dr. Maher present the material for around 90 minutes. After that, there will be question and answer session that will be followed by a conclusion. So without further ado, I would like to welcome Dr. Maher to deliver the lecture.
Thank you,
Please, Dr. Maher, the time is yours.
Yes, thank you for back to all introductions about my experience and previous experience. If my sounds and voice is clear. Do you hear me clearly?
Yes, I can hear you clearly. Could you please try to speak louder or
Yes,
close
sure.
to the microphone? Yeah.
Yes, sure. Could you please allow me to share my screen?
Yes.
Satu-satunya ala Sayyidina Mohammed. Here is the introductions of our today's lecture. Introduction to Data Science, Transforming Data into Actionable Insight. It's presented by me, Dr. Maher Aseeri. I'm currently working at Applied College, Najran University, Saudi Arabia. Let's begin with our session today. And I would like to begin, say Assalamu alaikum to everyone here. Salamat Batang. Since I was studying over there in Malaysia for more than 7 years, I have like fewer words in Malay. Okay, let's begin of what is data science. Data science is an interdisciplinary field of focusing of extracting insight from both structured and unstructured data. Beside that, we apply scientific methods, algorithms, and systems to turn all of these raw data into meaningful informations. All of this analyzed information can help and assist decision maker for making better decisions instead of making decisions based on experience. Also, data science use transform raw data, as I mentioned just now, uses machine learning models to detect hidden patterns or insights from those analyzed data, support predictive and prescriptive analytics, derives automations and smart decisions making. All of these about the introductions of what is data science. Next slide, we have here the foundations of data science. First of all, supports evidence-based decision making. We are making our decisions based on evidence, not based on experience or based on previous scenarios that has been faced by top management. Secondly, improve operational efficiency across industries. Besides that, enables personalizations at massive scale, helps predict market changes and customer behaviors, also reduces the risk using automated detection systems, and keep the companies competitive in all the digital and age. Let's move to our next slide. The evolution of data science started from classical statistics and mathematical modeling. It was the 70s, 1970s, then move and improved and grow with the computing power and digital storage with the first IBM computer systems at the 80s, 1980s, expanded with big data and cloud technologies starting from 90s, 2000s, machine learning improved predictive accuracy, deep learning transformed computer visions and natural language using and generative AI and reshaping creative and intelligence. As I mentioned just now, the field of data science evolved from classical statistics and mathematical modeling is accelerated with advanced digital storage and computing power. Then the came of big data, cloud technologies, as mentioned in 2000s, which expanded our ability to handle fast informations. And after that, machine learning took place, enhanced predictivity modeling, while deep learning areas like image recognitions and natural language processing. Data science is in our daily life. You are making data, everyone in our daily life, making data, sending text, replying to text through WhatsApp, reposting social media posts, commenting on those postings, or even the screen time when you are using your phone or sharing information through the phones. Every digital action generates traceable data. Also, the platform analyzes behavior to personalize experiences, analyze those data based on your experience, and provide recommendations, which will be discussed in next slides. Data are using in your screen time, data are sharing and posting social media platform in every day. All of those data, it will be raw, useless, unless we are making sense of those data by using data analytics and data science and machine learning models to test the accuracy of such data. Also, e-commerce logs every click and interactions. All of these are data commenting or rating specific product also is kind of data that we are using every day. As I mentioned, the interaction of the technology generates data, whether you are using navigation applications, scrolling through the social media or shopping online, your behavior is being recorded, data is analyzed to personalized experience, predict preferences, what you like, what you are preferring based on search or behavior. Also, personalized data or analyzed data can improve the service provided to clients and customers. For instance, your screen time, GPS locations, and online rating are all of data points being collected and utilized based on your behavior and provide customized services. Our next slide here is impact on our daily life. Data science impacting our daily life based on behind my tools. We are daily Google Maps using to suggest the fastest routes, Netflix and YouTube recommended videos for you based on previous videos you have watched, power recommendation engines filters spam and detects fraud, enhances smartphone features like Face ID, optimizes shopping, banking, and healthcare. Also use virtual assistants and chatbots by using data science. Here, in next slides, we are going to discuss the recommender system based on analyzed data. Recommender systems are powerful applications of data science. They are analyzed your viewing, browsing history, and compare it with others to predict what you would like next. Techniques like collaborative filtering and deep learning power and recommendations as you are on the platforms like Netflix and Spotify. These systems are designed to increase user engagement and retentions. We will in next slide discuss various applications as recommender systems. Google Maps traffic predictions. It uses GPS signals from millions of devices and combine or customize those data for showing the smallest or the shortest routes based on the routes you have used previously. It combines real-time information with historical traffic patterns, machine learning algorithms, then predict traffic congestion and automatically adjust estimated arrival times. This is how the app instantly detects roadblocks also and routes you are efficiently using or the shortest way to go to specific locations. They are all using traffic recommenders such as Google Maps traffic predictions. The second example here we have the Apple Face ID. The Apple Face ID uses a 3D depth map of your face and deep learning to verify your identity. It's secure, adapting to change like facial hair, glasses, or lighting behind the scenes. It uses computational natural language, special AI models used in image processing to ensure accuracy and privacy. Also, besides that, has extremely low false match rate, as it captures your face and detected when you are using Face Apple ID to log into your device. The next slide talking of explaining about the fraud detections in banking. Data science using detect unusual transaction in real time. Real data science plays critical roles in banking security, machine learning models, monitor millions of transactions and detect normal transactions in real time. These systems learn from the past fraud patterns to stop suspicious activities quickly. As a result, this reduces the financial loss and enhances customer trust. Here we have smart homes and IoT devices learn user habits to optimize energy, sensor generate real-time data for automations, security cameras detect motion with AI, voice assistants process natural languages, applications provide predictive maintenance. In smart homes, devices collect and process real-time data to automate tasks. For example, smart learn your habits to optimize energy use, security cameras use AI for motion detections, voice assistants understand and respond to natural language. These systems also support predictive maintenance and increase overall convenience. Another example of data science using in our daily life, generative AI generates text, images, audio, and code trained on massive data sets and the models, automates creative and analytical tasks, enhance productivity across multiple fields, power conventional systems like ChatGPT and large language models. Generative ID creates new content. It allows you to create new content like text, images, music, or code. Tools like ChatGPT are trained on massive dataset using deep learning models. These technologies are transforming creativity, automations, and productivity across industries, from writing software development to design. For example, when you are chatting with ChatGPT, or when you are requesting informations or data using ChatGPT or any other large language model, it interacts with you, keep asking you for them to provide more and details data. All of these data has been generated from AI models and safety models for next or used for predictive answers based on customer experience. Data, our next slide, as a new oil. Raw data holds value only after processing. As I mentioned, containing bytes of data has been generated every day without using data analytics. It won't be like raw data, useless data. Then we become to the terms big data, which is unstructured data, unused data. If we are using data analytics in our daily life, it will be labeled, it will be easier for data analytics. We are not reaching to make unstructured and useless big data. So data analysis allows the organizations, firms, private sectors for analyzing this data, make sense of this data, and creating an insight of analyzed data. And we are considering it at that as new oil. New oil, when you are storing them, analyzing them, make sense of or making decisions or in various fields. As I mentioned, raw data, it's hold value only after processing. Without processing, without analyzing, without storing it, making sense of those data, it will be useless. Requires cleaning, transformations, and modeling. All of these stages will be discussed later in this session. Organization treat data as strategic assist. Nowadays, all private and governmental organizations make their decisions based on this data and making numbers, like they are showing their productivities, showing their performance based on data, not based on experience. For example, Saudi Arabian government, they are making organization authority, SADAYA, called and responsible for organizing and make sense of those data. Saudi government also make decision based on analyzed data, not based on experience, and has been supported by Saudi government for every organization to make their decision based on analyzed data, not based on intuitions or based on experience or previous scenarios that has been faced by organization. Improve business intelligence and informations. If you make sense of those data, you will be improve business intelligence and make informations for technological aspect or sectors worldwide. Derives competitive advantages if you have data, if you are analyzing data, if you are examining your competitors, why they are making sales better than us, why they are improving their positions, why they are revenues higher than us. So if you are using data, analyze those data, make sense of this data, you will be, you have a competitive advantage among competitors. Our next slides will begin the previous slides, what we have mentioned in the last 17 minutes, all about, in general, data science, the importance of analyzed data, how the data can impact our daily life. Now we are trying to digging deeper on the topic and discuss how data with the numbers, how it will be organizations, trying use sense of data with the numbers. For example, here, data science derives modern decisions making. Okay, for example, data daily creations. We have introduced, as I mentioned just now, the previous slides with introduction, what is data science for people who doesn't have an experience or have background in what is data science, the importance, how it impacts our daily lives. Now we are digging deeper about data science and its importance of making decisions in various sectors. We know data science is about transforming data interactions, but why is this discipline is critical right now? Why it's important data science for us as academic people, as students, and people who work as a part-time in certain sectors or whatever? The answer lies in the sheer volume and velocity of data we are generating. We are generating data. The volume of data has been sent, stored, has been even analyzed. We are living the era of exceptional data creation. Every single day we are creating 2.5 quintillion. Quintillion means bytes of data. That's a number of 18 zeros, not million, not billion, not trillion, it's quintillion with 18 zeros. To put this in perspectives, 90% of all of this data, as mentioned here, has been created in just last 2 years. 90% of this amount of bytes has been just created for the last 2 years. Imagine for next 5 years how many bytes or how many terabytes will be created, analyzed, or saved out using or analyzing and making advantage of these data. The explosion of these data is like 90% of it has been created in just 2 years. How we can make sense of it all? Like how can make sense of this data? Or just discussing the amount of data has been increased in recent years. Data science emerged and discipline that tackle this data amount of data. This engine turns raw information into competitive advantage. Okay. The business world has recognized the value of data, which is why global data science market projected to be to 2026 by 274 billion. This is the investment that's going to be in next year. We are calling December now. It will be the investment of this 274 billion. This reflects the massive investment organizations are making to leverage their data assets. This isn't a niche field. It's leverage the core modern decision making across every industry. If you would like to make an effective decision, we have to make sense or analyze those unused data. What exactly is data science made of? Let's break it down to essential components that make up this new and modern field. Okay, when we can apply it in business intelligence, use data to create reports, dashboards to gain business insight. Traditional method after the reports BI being created and discussed. Predictive analysis, we are using machine learning to make predictive analytics and future scenarios by using advanced statistical method, which will be discussed in the next few slides. Next slide, explaining data science ecosystem. Now we are going deeper and deeper for the topic to cover data science topic, daily uses, data science. We just established that data science is critical discipline for making sense of data explorations. As I mentioned, 90% of all of those data just has been created in the last 2 years. But what skills do we actually need to be data scientist? This is the most important questions, or even data analyst, not data scientist. The answer is that data science sits at the interactions of 3 major disciplines. Data science are merging all of the 3 disciplines. Think of it as a Venn diagram where the sweet spot, data science, at the top, where all the 3 cell killers overlap. First, we have computer science. To become data scientist, or to be, if you are interested to become data scientist, first we have to have a strong background in computer science and programming. As you go deeper in data analytics, you need to have a strong background in programming, especially in R or Python in data science. This is the most popular languages, programming language to use in data analytics. This is your ability to write code, work with databases, understand algorithms, and build scalable systems. Without programming, you can't process large datasets or implement machine learning model at scales. Currently, and based on my experience, majority of people who works in data analysis, they don't have much experience about programming. This is just the basics of that programming, as the market is still growing. Some people still making sense or making decisions based on a spreadsheet in Excel, making sense of other software, which assists them to analyze data. They are not deeply on machine learning or implementing new models. Here it says, without programming, you can't process large data sets, implement machine learning models, and test accuracy of these models. Second one, to become data scientist, you should have mathematical and statistics. This is the theoretical foundation that helps you understand probability, make statistical inference, and test hypotheses and build mathematical models. Using statistics helps you to understand what kind of data I'm trying to analyze and what kind of models would be suitable for me to increase the accuracy of those models. Third one is often understand domain knowledge. In some scenarios, and based on my experience, one of my colleagues was working with Indian companies. We are trying to solve problems that they have faced in 2021. We tried to understand the domain knowledge because it was like medical industries trying to sell drugs. After 6 months of investigating some kind of data, it wasn't accessed by us. It was sensitive, and the owner of those organizations helped us to access those data. After 9 months of investigations, after that, we couldn't complete the project because we didn't understand the domain that we are trying to solve. For example, if your domain is about business or data management or information system, technological part, and trying to understand the domain which is about mathematical or nursing or chemistry, it's very difficult for you to go deeper with the data, understand those data, and make sense of those data. Understanding the knowledge of specific field you are working, whether it's finance, healthcare, marketing, domain knowledge, helps you to ask the right questions. Understanding the result correctly and communicate findings to stakeholders. Sometimes, and some scenarios based on my experience, the stakeholders ask us to analyze those data and make sense of this data, why their selling is dropping, the customers' feedback is low, the rating is not that much. Planning first with the plan that we planned, and then we decide the budget, we form the team. 2 months later, we are trying to reach to that stakeholders. We can't. Why? They are changed. They are interesting in analyzing data or in this project. They might decide this is not the right project that I'm investing in. So understanding your stakeholders for long term and allow you to start with confident that you are going to invest your time, invest your knowledge in the right project. Okay. Again, to recall, to become a data scientist, you have to have basics knowledge, data science, computer science, statistics, and final with understanding domain, understanding the requirement of your stakeholders. Next slide here, we will be discussing the data science workflow. This workflow, this diagram, known as Osmin framework, 5 essential phases for project success. Following the discussions of data science ecosystem, let's look at how these skills are applied in practice. While every project is unique, must follow a common iterative workflow that we can break it down into 5 essential phases. The first one, collecting the raw data. Before collecting the raw data, ask yourself, as you know, the internet, some of the information, or the majority of information is not reliable. Okay, ask yourself, am I spending my time at the right source on collecting data from? Because this is the first essential part of data collection. Sometimes you are spending time, data engineer, for larger project. Unfortunately, the data engineer doesn't know or doesn't understand the source that the data they are gathering from. Is it reliable to allow me to go to the next slide, processing them? Otherwise, you will go back to this first step and recollect again, and recollect again. You won't move to this third steps unless you spend 6 or 8 months of data collections. That's why the first or the vital, the crucial steps in data science or data analytics, knowing the source that you are collecting data from, understanding the data, the trends in the data that allows you to go to the next or the final stage, which is visualization of the and reporting of those analyzed data to be ready for make a decision. We will discuss all of these 5 phases after they are deciding the data that you would like to collect from data analytics, then going to data analysis. First one, ask and obtain. This is where you define the problem. What is the current problem we are facing? Why the sales has been dropped? Why I'm facing this kind of issue? Then the next stage is collecting data. This is where you define the problem you are trying to solve and then gather the data you need. Before and the between, asking yourself and collecting data, knowing the data source they are gathering that from is very crucial. Defining the problem clearly, the most critical steps. Many projects fail because they solve wrong problem. many scenarios has been occurred during working as data analyst. Maybe relationship affect those desired, maybe friendship, whatever, maybe the friendship of the manager, of the CEO, CIO of the organizations. Okay, ask him to like analyze those data. Why my friend's company is not performing well? Okay, you spend all of these times, then at the end you decide to not continue this project because why? Because all of these steps was wasting of time because his friend has only 3 staff, 4 staff, or 5 staff, and he is comparing himself with the biggest or bigger company, which has been like 25 years in the market. So these scenarios affect the way you should start your project or not. Using web scraping, now AI helps you a lot of collecting data, write data, and make sense of this data in just minutes. Explore the model, the data they have been selected or data that has been collected. This is where you get your hand dirty. None of labeled data it's cleaned as you mentioned. You are gaining or got the data, even from the databases itself, company databases, whatever, it's not cleaned. This is where your hands become dirty. You will spend a lot of time cleaning the data, handling missing values, and performing exploratory data analysis. Often 80% of the project time spent here. Data cleaning. Sometimes the data after cleaning, it seems that it's useful for cleaning or useful for the next stage. But indeed, sometimes it will return you to the first stage, data collection. For example, culture sometimes affect the way that we are cleaning data. Or shortcut. Sometimes in USA, they write the dates, but for example, today, 6th of December, 2025. Other country, just shortcut, 26 of 12, 25. This is when you clean data, when you're cleaning data, make an issue for it. Different formatting allows you to go back and reorganize or finding the source that based on your formatting, or it will take a lot of time here at this stage. Cleaning data based on cultural background, even the company's policies or governmental policies. Then once the data is clean, finished data is clean, go to explore data and communicate effectively or the data they are being analyzed. After that, we are making modeling, testing the modeling, deploying this model, and a check for the accuracy of this model, either the right model we are using or not. Let's say if you have modelings, the accuracy is like 85 or 90, which is quite high rate in data modeling. After that, go to visualization and reporting, then decision making process take place from top management. This is an iterative approach. It's the key to success. If you're reaching here, sometimes visualization is not understandable by decision making, you will go back, iterate all of this process again. Since the visualizations, it doesn't make sense for decision making. This is how data science work step by step, as I have mentioned earlier. Decide at the first stage, the planning stage, which data source are you going to use or collect data. Even sometimes first party which is the company or the organization's data, it's not cleaned, it's not organized, it's not even reliable to make or go to next stage. Here we go deeper about essential Python libraries. Okay, the core open source tools powering the modern data science stack. As an NumPy has been used for numerical computing, providing support for large multidimensional arrays and matrix. To execute those phases from obtaining data modeling computing, we have reliable for source ecosystem primarily built around Python. Python has become the dominant language for data science. I have mentioned in the earlier slides 6 essential libraries. First, NumPy is the foundation for numerical computing. As I mentioned just now, it gives Python the ability to handle large multi-dimensional arrays efficiently, which is critical for mathematical operations. Next, Pandas. It's your workforce for data manipulations. It introduces data frame structure, which is like a superpower spreadsheet in code, making data cleaning and transformations dramatically easier to follow. This is Pandas. Sometimes to clean data, you just write one line of code, sometimes halfway, sometimes you're creating page of code to clean data if you are not familiar with those libraries. Next is TensorFlow. It's the core plotting library allowing you to create highly customizable static visualization. And beside that, Seaborn, the well-known libraries for making sense of data for me. I'll begin cleaning data, okay? Move those data, import it, then visualized it, use Seaborn. This process allows me to see the trends, understand your data, explore how your data, how it goes. For example, like I'm exploring the data and auditing it in Seaborn to see how the trends in first 3 months of each year, allowing you, asking yourself why the sales has been very high the first 3 months of the year, then it allows you to understand your data more. I'm using Seaborn. Nowadays, they have many like various numbers of AI tools which allows you to visualize the data at early stage. Next, we have Keras. It's open source Python library for building and training deep neural network. It's user-friendly, making it ideal for both beginners and advanced users. Next, we have like Jupyter Notebook, interactive computer environments. It's well-known, allowing you to create documents while live code in place, equations, and visualization. Jupyter Notebook is well-known platform or libraries for using or manipulating and importing data. We'll be getting enhanced on all of these tools pretty soon. Next slide, understanding the machine learning paradigms. We have just covered the essential tools for data science, as we mentioned earlier. Now let's dive into the core of modern data science, machine learning. It's crucial to understand that there are 3 fundamentally different ways machine learn and solve different types of problems. First, supervised learning is the most common paradigm in business because we have labeled data. I'm talking about the data, or we already collected the data, we already have data, and labeling them. It usually comes from the company databases. It's organized, labeled. That's why we call it supervised. Supervised means it's labeled, cleaned. An example here, learn from labeled example, teacher to map input to output must command in business. Example, map filtering, price, predictions, and medical diagnosis. We come to the second one, unsupervised learning. Unsupervised learning meaning that the data is not labeled, it's not cleaned, it is considered as unstructured data. The model explores unlabeled data to discover hidden structure without explicit guidance. Example of it, customer segmentations, detection recommendation system. The third one is reinforcement learning is completely different. Here, an agent learns through trial or error, interacting with environment and maximizing qualitative rewards. This is the technology behind game playing. It's use AI and computer system. Understanding these three paradigms is the key of selecting the right approach for data science challenge. But choosing the right paradigm is only the first step. Next, we need to ensure our models actually work in the real world, not only testing the model. We have to deploy it in the real world, which brings us to the critical topic of validation. Before we begin to decide which you are working the project, which data or which paradigm you are going to use, you have to decide supervised learning, which is easier for like beginners, data analyst, or data scientist. Sometimes unsupervised learning, challenging you for understanding data and making insight of those data. Here is data visualization insights, line chart, bar chart, scatter plot, histogram, heat maps, and box plot. Previous slides or previous discussion about the data. Making sense of data, understanding your data, analyzing your data in a perfect way without visualizing it, which it make it easier for the decision maker to make decision based on these visualizations is very crucial, as it's for a decision maker or top management who would like to make a decision without this visualization. It will be very difficult for him. Data for him, just like spreadsheet full of numbers, full of columns, rows. There is no meaningful of this data. If you are not using data visualizations for the decision maker, it's very difficult for him to make a decision based on those data. Okay, line chart based for showing trends and changes over continuous time intervals. A bar chart based for comparing quantities across distinct categories. The scatter plot based for identifying relationship and correlations between two variables, which is widely used when you have like a small amount of data. Histograms based for visualizing the frequency distributions of data set. Heat maps, sometimes it's used for understanding data based on machine learning models, such as key forest, k-mean, T-forest, Maher, and so on. Based for visualizing complex data density correlation matrix. Box plot, based for statistical summarizing, showing, and outliers of data. Now let's look at how these tools and techniques are applied in real world. Let's begin with we have covered the entire data science pipeline, from the tool to models to visualization tools that allow the decision maker for making their decisions. Now let's see the impact of those concepts across major industries. These real-world applications demonstrate immense value data science creates. In the healthcare, machine learning models are improving early cancer detections accuracy by 30%. Imagine the machine learning models that allow us to increase detection of the cancer by 30% and various or a huge number of research being conducted for improving these numbers. These are truly saving lives and transforming patient care. In the finance sector relies on data science for security and efficiency. Fraud detection system now achieve over 95 accuracy of detecting the fraud, predicting billions of dollars in transactions, and algorithm trading drive market secure. Also, e-commerce like Amazon have built their business on that Amazon revenue by predicting what you want to buy next. Like now, on 6th of December, you are buying specific stuff from Amazon. They have a machine learning model to predict what are you willing to buy in the next purchase or next specific amount of time. This is the foundation for autonomous vehicles in the marketing. Targeted ads show 2 to 3 times higher conversion rate and ads because customer expectation and segment analysis. Here, the examples of how real world applications, I will discuss it further in the next two slides. These predictions and finance, e-commerce, transportations, route optimization. Instead of going to point A, it takes you like 35 minutes. The predictions or real-world applications based on machine learning models try to shorten the durations from moving from point A to point or destination B. Demand forecasting, autonomous vehicles, and marketing, customer segmentation, targeting specific people or specific ads to based on their interest. Social media content recommendations, fake news detections, and user behavior analysis. Like Facebook uses machine learning for 6 billion predictors per day. Now we have complete two sections. The first section, which was about data science in general, their uses, daily uses, and how it's impact our daily life. We discussed and went deeper to ecosystems, the libraries that has been used for data science project. Now, from these slides and go on, it will simulate one of the most important certifications in the world in data analytics, which is Google Data Analytics. These slides will simulate the course or the certifications of Google Data Analytics, which it will take from 2 to 6 months. I have summarized this course, like we'll discuss it in like 20 to 25 slides, which will be impactful for the students who is interested in gaining certifications, Google, or either IBM. I'm planning in next session or next lecture, I will discuss on summarize IBM data science certificates, giving the participants like the summary of all of those certificates. As you know, it takes 3 to 5 months or 3 to 6 months for completing such courses while you are busy and engaging with your assignments, projects, and students and university daily life. Next semester, we will discuss the importance or the summary of IBM data science. I will take a break for 1 minute. Drink a water, have a break, then we will come back.
Excuse me, Dr. Maher.
Yeah,
Oh, right. Okay.
just
You could speak louder and continue.
yes, sure. We reached to the last sections, which is simulating the course Google Data Analytics certifications. We will discuss the various phases and also discuss real-time case study. Data analytics from raw data to actionable insights. Okay. First point, understanding 6 phases of analytics, which will be discussed later. Next slides. From business questions to measurable values, from asking why we are facing such scenarios or why we are facing dropping in sales or dropping in rating or customer purchasing or and etc. Then we'll move to structures of growth used globally, which is the 6 phases. It shows labels, repeatable outcomes for implementing or asking those questions and going through each phase in details. Foundation for your upcoming slides will be discussed soon. Okay. Here, data analytics powers modern business, transforming raw informations into strategic action. To achieve that, you have to go through various phases and discuss it with identifying your stakeholders, which is at the beginning of each project. Okay, that is raw as new currency nowadays. Analytics is the engine that extracts its values. As I mentioned earlier at the first of our lecture here, if you are not making sense using data, it will be useless unless you're making insight, creating an effective and impactful decision making. This is not just a technical skills, it's strategic imperative for every modern business. Data analytics transforms subjective guesswork into objective evidence-based strategy. It enables predictive capabilities, allowing companies to anticipate market shifts and customer needs before they happen. This is not limited to one sectors, whether you are in healthcare, finance, or retail data-driving decisions. The market size is projected hit 655 billions market size by 2029. This is the source for business insights, okay, which shows the massive investment and opportunity in this field. So how we can harness this power? How can we start analyzing data, even for like department, in our department, make it like a culture, organizational culture. We are not making any decision unless we have evidence. We are making this decision based on numbers, based on analyzing those data. Either the data comes from a first party, the organization itself, or it comes from second party or governmental party, which considered as third party. Okay. Third one, applicable across all sectors: healthcare, financial, and retail and governmental. 13.5 annual growth rate. Okay. To consistently extract value from data, we need repeatable progress or process. This is the complete data analytic life cycle and consists of 6 essential phases. We all start with phase, ask phase. Okay, this is simulating Google Data Analytics. It begins with ask. Define the problem. What is the problem that I'm facing now? What is the stakeholders' needs? What the expectation of our stakeholders out of this project or solving real-time problem? For example, as I mentioned, why we are not targeting, for example, 2 billion or 2 million per month? This is the complete data analytics life cycle. 6 essentials. First, we start by ask why and define the problem and stakeholder needs. Then we prepare the data, collect and organize relevant data. Either it's from the organization itself or from market or from any other sources. Next, process and where we clean and transform data. Transform and process, clean and transform data that has been imported from various sources. Next is extracting insight using statistical methods, starting analyzing this data. As I mentioned earlier, 80% of the time you will be spent here. 80 time of your time you'll be spending here because making it quickly or not making sense of stages going through the process, it will return you to the first stage, asking again. And as I mentioned, it's an iterative process, not only starting with a lot of mistakes that have been faced or discussed with the colleagues. They directly start here. Collect and clean without asking why we are facing this kind of issues, why we are not achieving our target after like 6 months of beginning. Like we have been started for 6 months and we are not achieving our target. Then you will ask again. Only then we analyze using statistical methods and extract insight. After that, we share our finding through the clear communications and visualization. Sometimes the stakeholders at the first stage, they ask you to like start the project of why we are having these issues. After 6 months of working, spend a lot of times, then when you share it with the stakeholders, they are not anymore interested in this kind of project. This has happened a lot in industries. It happens a lot. Maybe one of the reasons so suddenly it has been increased. The sales has been increased. They are performing well, and they are not interested anymore for sharing it or making this the last stage of acting of analyze data. Sometimes it happens during my experience in some projects. It happens when we work on the project, we finish them, we share it with the dean or top management. Okay, we have faced like these scenarios after like 2 years of computer science students. They are taken over or dropped the subject and they are not anymore in the university. When we share it with the decision maker, they are not making any decisions because the problem has been solved or the top management are not interested anymore in this investigations. Okay. Again, we are discussing in details ask every great analysis. Start with the right questions. Asking the right questions allows you to understand the issues or the problems easier. Okay. The ask phase where every great analysis began and is often most overlooked step. You can have the best data and the most powerful models, but if you are solving the wrong problem, your work is useless. This phase is about establishing the foundation by defining the clear problem statement. What the problem that I am facing, why I am having it, what's the stages that I have to go through to face or to solve this problem. You must identify your stakeholders and understand their expectations of this project. crucially, you need to determine success metrics. What measurable KPIs will define successful outcomes? Will KPI define the successful outcomes or not? A common starting with identified questions like why are sales down? Refined questions like which customer segments stopped purchasing in question 3. And in details in why, 5 whys questions which ask you, which allow you to define the problem clearly, you have to use this strategy or method for problem and drop last quarter. The problem we have, sales dropped last quarter. Why did sales drop? This is the first why. Because the customer order decreased. Why did the customer order decrease? Again, go deeper. Because website traffic went down. Okay, why did the website traffic go down? Go deeper. Because our marketing company or companions had lower reach. Okay, ask again deeper. Why did the companions have lower reach? Because the ad budget was reduced. Okay, then ask why the ad budget has been reduced. Then you arrive to the basic of first questions that allow you to understand the problem that you are facing within your company or within your organization. Okay. Again, recall, define the problem statement, identify the stakeholders, determine success metrics, KPI, either using KPIs, or find the root cause. In finding the root cause of the issues, we have to ask 5 questions, 5 whys. Like for examples, we have sales dropped last quarter. Why did the sales drop? Because the customer order decreased. Why it's decreased? Because website traffic went down. Why the website traffic went down? Until you arrive at the base of the main cause of the problem. Common pitfall, jumping to the solutions or analysis tool before fully understanding the problem leads to waste effort and irrelevant insight. For instance, you are just not making complete or clear big pictures of the main root of the problems. You just jump directly to the solutions, the tools that we are using. Okay, your company is big, your company is a technological company, they have a budget for spend billions of dollars in AI tools to help us to analyze those data and whatever without getting clear pictures of the main road. It will be a loss of time, effort, if not asking correctly. Okay, then here we have the case study. Netflix reducing customer churn, applying the ask phase to solve critical business problem. For example, here canceling users are canceling subscriptions. Okay, here refined questions. Which user segments have a high churn rate? At what point the customer journey do they leave? What content references correlate to retentions? How do viewing patterns offer between retained and churned users? Here they are asking what kind of problem we are facing, or asking why this scenario has been occurred. Here, success metrics, 15 detections and 15 or 20 time increase. The outcome, by asking the right questions, Netflix identified that user who didn't engage with personalized recommendations in the first 30 days were 3x more likely to churn, to not complete paying or subscriptions of the next 6 months or 3 months. Here is details of the ask phase. As I mentioned here, the outcomes, stakeholders in these scenarios, product team, content acquisitions, marketing, and finance. at the end of by the end of this session, I will share, ask you to make case study based on the problems that you are facing, either within your studies, within your financials, or whether your courses that you haven't completed, and etc. The next stage is prepare, gathering the right data for analysis, identifying, collecting, and organizing the raw materials for analysis, the key activities, identify data sources, determine whether the required database, APIs, files, and how to access it. In some scenarios, you are trying to prepare your data and trying to acquire the data from different sources. The data that you are trying to access is not accessible, either to internal policies, either to governmental policies or regulations, and you won't be able to find such data. For example, you are trying to, as we are academic, where you have certain research, certain information that you are trying to find the support in previous research, you don't have an access to that papers. So it will be difficult for you to support data or support your evidence or the ideas that trying to discuss. The same goes here when you are identifying or finding the right source for data analysis. Define metrics and KPIs, establish exactly what need to be measured to answer the business questions. And the third issue is security and ethics, ensure compliance, privacy laws, and ethical data usage standards. Sometimes that happens a lot. You are trying to solve an issue or importing data that has been restricted by data privacy or data security, like patient's information. This is considered as challenges of data analyzing such data or working with medical industries. The majority of data that trying to understand, trying and make sense of it, trying and analyzing it, they are protected with the privacy and security laws. So this is an ethics also plays vital roles in gathering data. Data source types, here we come from the first party, all the first party data the organization collects directly from its audiences, from surveys, from databases, or CRM records, website analytics, transaction links, and supply chain data, partner marketing. All of these data considered as first party data. Second party data is data collected by outside organization and sold or shared publicly. At this point again, we have to mention that the data source that you are collecting from second party data, they are just selling data. When you are buying it or importing it, it will take like 80% or 90% of cleaning it. After the cleaning is finished, going to next part of data analysis, which is for visualization, it won't make any sense. The majority of scenarios happen when you are relying on second unreliable data source. Third-party data, governmental sensors, or weather data, industry reports, etc. Okay. Well, if you are interested, or if you are already data analyst or data scientist, the importance of understanding the way that you are collecting data is very important. First stage, where I am going to collect data from, is it reliable? how it has been collected, how long it would take for me to clean this data and make sense of those data. Building robust data collection plan, strategic planning to ensure data quality, it's very important and most challenging factors in data science nowadays. Relevance and accessibility. Okay, 5 critical questions. Where does the data live? How often is rated? What is the level of details? Who controls access? Is it raw or derived? Okay. Now we know that what data we need and where it might live. We need a strategic plan to collect it. Building a robust data collection plan is critical for ensuring that you are trying to get high quality, which is, for me, as I said, I'm selling data, I'm considering it as a good quality one. How to measure it, or how to ensure that the quality of data is based on the standard. Nowadays, until now, there is no standard. It's very difficult to ensure that data quality meets the standard of being considered as a good quality. Relevant and accessible when you need it. We need to answer 5 critical questions about every piece of data we are collecting. It first, where does data live? Knowing the locations is the key for access. Second, how often it's updated. Now we are in 2025, and you might be interested in data that has been collected or updated in 2013, especially for the technological aspects or firms. It doesn't make sense for me if I buy it now and clean it. It makes sense and afford money, stuff, plan. Then you are trying to update or working with and not updated data, aged data. And one of the most challenges data when you are trying to collect data from various unreliable sources. The frequency determines if your analysis is current. Third, what is the level of details? Sometimes you are importing the data, the whole column of more than 2,000 rows, just writing phone numbers. The majority of the columns is empty, uncleaned, messy here and there. So this kind of factor is very important when you are importing data. And almost on each stage or each data that you are importing, certainly you will face this kind of issues. Do you need individual transactions or just daily summarize? Fourth one, who controls access? You might have the access for 3 months, 2 months, then 5 months, 6 months, like 1 year later, would like to access this data to manipulate or whatever. It has been controlled by someone and unreachable. Ownership, permissions, and security. And fifth, is it raw or derived? Understanding the lineage helps you to trust the numbers. To make this work, always centralize your documentations. A single source of truth of data definition or prevents confusion. You should also validate your data by cross-referencing multiple sources to ensure accuracy. Always plan for scale, making sure your storage that can be handled future growth, and crucial best practice in checking for bias. As I mentioned earlier, you are importing data which is not usually cleaned, organized, and based on your expectations. Don't expect too much from the data, even from the reliable data, even from the data itself, or databases of the organization. Sometimes they are producing unorganized data, which is one of the challenges also. One of the advice that has been I have been asked from one of my colleagues. I asked them, first, if you are interested of gathering data and later on selling those data, please make sure about the systems, building or implementing the system that allows you to produce clear, understandable, and reliable data later on if you would like to use it or sell it to another organization. Example of e-commerce data map here, click stream, product catalog, SQL database. We're using web analytics. Customer profiles, we are using database or data importing it from CRM systems, or competitor pricing we can use, or the data source we might be using like external APIs. And then for making central data warehouse. One of the examples that while I was collecting my data during my PhD, it was collecting data from top management in Saudi universities. Unfortunately, they are not like familiar mentioning about why you are accessing this data. Sometimes data is it's open data. It's not secured or not accessed, but sometimes not understanding the importance of data for others allow them not to secure or afraid to share it with others. Nowadays, the Saudi government has implemented a system that each website has to provide open data, especially for universities. Those data sources can be considered as reliable data sources since it's comes from trusted website and monitored by Saudi government. The next phase is processing the raw data. Okay, here process transforming raw data, ensuring data quality through cleaning, validations, and standardizations. Check availability, check integrity. It's not manipulated, it's not accessed. Clean data, remove duplicates, fix errors. This is common activities when you are working with data. For example, here we have raw data. Okay, here is a shortcut NY for New York, as I mentioned earlier. Maybe the company culture or the company format that has been applied, we don't have to write New York, NY. So when I import this data, how could I understand that they are meaning that NY is shortcut for New York? Here's a sales Chicago, this is the sales is null, the data is missing here. Again, New York, and data is here missing. The correcting process data clean. Make it clear if you are making New York, keep it as it is for all of these column. The same goes with Chicago. If not providing any numbers, just put it as zeros or try to find the, the mean of all of this data, the average. Here's an example of transforming data from raw data to clean data. It's not as simple as I mentioned here, these two pictures. It's a lengthy process. It takes time, it takes effort for you to understand and clean your data for preparing it for the next stage. As I mentioned, 60 to 80% of your project time, it will be spent in cleaning your data. Next, we will look at the essential tools help us to manage the massive cleaning effort, efficiency of data. Here is the leveraging the right technology of efficient data cleaning. One of the examples is Python, Pandas, R, and SQL. Okay. Data processing is time consuming, so we need the right tools to make it efficient. We rely heavily on programming languages and specialized software to clean and transform data. It comes to place. Python take the place, especially with the pandas library as the industry standard for creating large datasets. Pandas gives us data frame structure, which makes cleaning and transformation incredibly fast and intuitive. The same goes with R, another excellent language often used for specialized statistical transformations, and SQL, but is still widely used for navigating data, importing data, but not for a huge amount of data, maybe small data set, but for making a huge data, importing them, manipulating with them, Python and R take the place for fastening the process of data cleaning. Python beyond language specialized software can help. Open Refine is powerful, also attractive tool, especially designed for cleaning messy data. Excel, Excel is still useful for quick explorations of smaller datasets and platforms like Traficata, and the code snippet shows how simple use pandas to perform core cleaning task. In many scenarios and different scenarios, during my experience, it's like Excel still the favorite tools for cleaning data. I attended the course in 2019 in Australia. The data scientist that gave the lectures, he mentioned that it was the best effective tool for data cleaning rather than using R or Python. Once your data is clean and processed, we can finally move it to the most existing phase, which is data analysis. Okay. Core statistical techniques from summarizing data to interpreting relationship and predicting outcomes. Okay. We have discussed overall data science workflow. Now we are going to dive into analytical engine that powers it. For example, statistics, language of data science. You can't truly understand your data or build reliable models without solid background of these core techniques. We can break these techniques into three main categories. First, descriptive statistics, which are well known by everyone, help us summarize and understand the characteristics of our data. This includes measure of central like the mean, median, model, and measure descriptions like standard deviation, and variance. Second, interval statistics allows you to draw conclusions about larger populations based on sample. Here it comes a place where the hypothesis being testing in this stage and using tools like t-test and p-values to determine if our findings are significant, supported, or statistically significant. Finally, advanced techniques move us into the modeling predictions. At this stage, we are using regression analysis, clustering, for example, key means or the nearest neighbors, or classifications, logistics, and also using as a time series, trend analysis, and seasonality. Okay, this is the core statistical techniques that you must as data scientist or data analyst be familiar with those statistics. Okay, now that we know statistical tools, let's see how we can apply them in the first major analytical steps. Exploratory data analysis. EDA, detective work of data analysis. I'm getting to know your data, ultimately before modeling. EDA is a critical step where you investigate data set to summarize their main characteristics, often using visual methods. Here, understand variable distributions, detect outliers, and identify the patterns and trends, test assumptions for models. The goal of EDI is to work complex models to understand variable distributions, detect outliers, and could screw your result, identify patterns and trends, and test assumption you will need for your models. It will be spent like 30% of your total analysis time on exploring your data, understanding your data, seeing the trends of your data, trying to explore why this kind of visualizations has been occurred at specific time under specific circumstances, or scatter plot, for example, is why this is the higher point, while when we began like first month, then the sales explores like increases until it reaches to the highest rate. This kind of visualization allows you to understand the trend and explore your data, how it goes, and how to make meaning of these visualizations tools. Pro tips: spend 30 minutes on your analysis time on EDA. The insights gained here often lead breakthrough discoveries and prevent costly modeling mistakes. In some scenarios, sometimes I'm working with the team, and data scientists believe that his experience is higher than the theories or the steps or stages that have been faced or are going through, and he's deciding that, okay, go to the next step. Since I have an experience on EDA, we have faced similar scenarios previously. Okay, we won't spend 30% of ensuring or exploring your data. Okay, go to the next stage. Unfortunately, at the last stage, you will observe that the model that you are testing or the model that you are trying to generalize your data based on, it's not effective. You will be again going to the first stage, and takes time for your team, cost, the delivery of your project.
Sorry to interrupt, Dr. Maher.
Yes.
So because the time is limited, perhaps this will be the last slide, or you have a closing slide, and then we can go to the questions. Okay.
Yeah, this is, anyway, it's just the last stage, which is sharing your analyzed data and turning that into compelling stories. The key activities here are create visualizations, design chart and graphs that highlight key finding clearly and simply. Tailor the ideas, adjust the tone. Sometimes decision makers doesn't have an experience or doesn't prefer some kind of data visualization. You have to align your strategy or your tools that you are using to be aligned with the experience with decision maker. You don't have to be like make complex scenarios. He's preferring this kind of visualization, and you are making different time. He finds it's difficult to understand and whatever. Try to create the visualizations based on your audience, tailor to audience. Build narrative, structure your presentation with clear beginning, middle, and end. Develop dashboard, which is the most important and most useful tools nowadays. Allows you to make decisions based on data, analyze data. Sometimes they are to management, they are using live dashboards to see how it goes, performance, the project, or whatever. by the slides, we are reaching to the end of our presentations. Here, effective data visualization principles, line chart, bar chart, pie chart, scatter plot, design principles, simplicity, color strategy, and context. Avoid making I-axis grade differences. Also avoid 3D charts with predictives and reliabilities. Avoid a lot of colors, disturbance colors, a lot of colors here and there with Y and X. It's not clear, the title is not clear. What you are trying to deliver with your visualization is not clear. Try to avoid these mistakes. Here we reach to the act from the side to impact. We are getting the visualization. You already got the analyzed data. The first is acting. Decision maker act about the solutions that has been derived from the visualization. And this is the key activities: develop action plans, prioritize recommendation, assign ownership, and monitor outcomes. Here, this case study, we don't have time to discuss the case studies. If anyone would like to ask. Thank you for your listening attentions. If anyone would like to ask here section or the session for questions and answers, thank you for your attention. Sorry for being like takes more than 1.5 hours.
Yeah, thank you so much, Dr. Maher, for giving this is such a comprehensive presentation. So I think we'll have a vibrant discussion after the lecture. We have around 20 minutes for the question and answer. So there's already 6 questions in the chat box. So first is from Jirsa. Perhaps Jirsa, can you deliver the questions directly? Are you there?
Yes.
Okay, Jirsa, you can deliver your question.
It's me. My name is Jirsalendra Sastra, and I would like to ask about fraud detection in banking. What are the biggest challenges banks face today when trying to detect fraud in real time? Thank you.
Thank you for your questions. It's very important questions. Nowadays, the biggest challenge is in fraud detections. They are trying, like the hackers or the people who try to hack or fraud people, they are making different techniques and models. At the other side, the people who work to in IT, in banking or whatever, are trying to develop new models that not allowing the hackers or the fraud people to hack their system. Like this is the big challenges. They are inventing new technologies. They are protecting themselves based on new models, and still challenges. A lot of papers or research has been published in using different type of models to protect their fraud detections, to improve the security of banks and their customers.
Okay, thank you so much, Dr. Maher, for the answers. The second question is from Muhammad Rafi Noviansa. Rafi, if you are here, you can also deliver the question directly.
Okay, excuse me, my name is Muhammad Rafi Noviansyah, and I would like to ask about the essential Python library slide. So the given that
your sound is not clear. Can you repeat it, please?
So I'm outside right now. Maybe it's not really clear. Sorry. Maybe I can ask in the chat.
Yeah.
Okay, so I will have to read the question. So Rafi asked about the essential Python libraries. So given these libraries are the industry standard, which core open source library is facing the most disruptive competition from newer specialized tools right now? And what limitation of the original library is driving this shift?
Actually, the libraries that I have mentioned, majority of them like open source. Sometimes you are going advanced or trying to use subscribed kind of libraries that will gives you more functionals and more advanced options to use. Currently in the market, this is the most major used libraries. For me, I'm using pandas. So it's easy for you to import the data, clean the data, just half line of code without any disruptions or updating in the code. It's stable tool that I'm recommending everyone, especially data analysts, for using pandas as Python libraries for its easy of use and stable performance. I hope
Okay, thank you. Mhm. Yes, Rafi, do you want to comment on that? Okay, I think that is clear from Dr. Maher. Let's move into the third question. It's from Anas bin Mahfoud. Anas, are you here? Okay, so let me
Yes,
read the
yes, I
question.
am. I'm here.
All right. Okay, good.
Okay.
Thank you.
Dr. Maher, despite the significant progress in data science models, why do many real-world applications still fall short of ideal results? Is the issue really with the models themselves, or with how organizations approach and use the data science? Thank you.
It's a good question, Dr. Engineer Anas. It depends on the scenarios that's facing by the organization. Some organization using data science and using specific models for testing their accuracy in the market. Sometimes they found that it's effective, it's impactful. Sometimes other organizations, it's not. They are finding this kind of models. It's not applicable with the scenarios that you are facing. You can't just generalize that we are using this model for this kind of scenario. Each project or each scenarios or each challenges that you are facing using different kind of models with different kind of organization. For example, company A, they are facing dropping in sales. They are making specific or center kind of models, while it's another company trying to use the same models, while the company is similar in numbers, in terms of number of staff, the scenarios or challenges they are facing, it might be not applicable with other companies. I hope I'm answering your questions, Engineer Anas.
Yes, it is. Thank you so much, Dr. Maher.
Okay, thank you. The next question is from Axelino Berwin. Axelino, are you here?
Yes, I am here. Are my voice is clear?
Yes, it's clear.
Okay. Excuse me, my name is Axel Berwin. I would like to ask about the data science in smart homes. What are the biggest challenges for researchers face today to apply the data science to improve efficiency, security, and the personalization in time?
Hello, I can't hear you clearly. Do we know challenges that has been faced on data science, especially in smart homes? Is that your questions?
Yes, I think it's about data science in smart homes. So what are the challenges in terms of security and personalization?
This is the biggest challenges, not only in IoT, smart homes. This is challenges of the majority of uh, the whole life cycle of data science. Security and privacy, you can apply it. It's challenges for collecting the data from the government itself, as I mentioned. IoT also has the security issues of sharing or manipulating the data from device to another device within the home. Also, the smart homes data, how can be secured of other people's not being hacked before implementing it in data science. Now we are, the challenges is the data itself. Who has the access to this data? How we can secure this data to move to next stage, which is making sense of this data. Security in these scenarios and privacy take place, as it's important before we move from this section to another stage. How can we transfer this data from the devices of smart homes, either it's fridges, smart fridges, smart TVs, screens, whatever. So how the data has been we secure this data, then we move it to next stage, which is data science and use of this, make sense of this data. Now the challenges are not updated with the researchers has been published specifically with the smart homes and importing this data to make sense, transferring it to make sense of it, analyzing it. It's a big challenge not only in smart homes, it's all the life cycles or all sectors of data science. How we can secure data, then we try to make sense of those data. Imagine that your system allows you to analyze the data, okay, importing the data from smart homes, analyzing them, but the security itself, your storage or your systems is not secured. So what is the benefit of making sense of this data and apply data science if the data is not secured and private? I wish I answered your question.
Okay, so thank you for the answer. We still have another two questions. Please bear with me. The next is from Izas. Izas, can you deliver your question?
Yes, I can. Um, Excuse me, my name is Izas Aktif, and I'd like to ask a question. So, as AI starts generating more of the internet content, such as videos, images, text, and so on, are we risking a feedback loop where models that use data get trained with AI-generated content slash data rather than human real-life data? In short, I'd like to ask how data scientists distinguish between organic human data and artificial data in today's age. Thank you.
Thank you for your impactful questions. The questions was like how the data scientists differentiate between data has been come from AI, generative models, and the original data. The simplest answer will be the way the data has been organized, the way the data has been labeled. So we identify that data has been labeled. If data has been labeled, organized, it comes in impactful ways, easy to clean. It doesn't take much time for cleaning, then we can proceed with the next stage. The normal data or the original data, always it comes messy, it comes in different format, it takes time for you to organize it, clean it, even takes more than 80% of your project or analysis stage of cleaning those kind of information. As well, beside that, there are also AI tools that detect this kind of data. Is it original data has been selected or gathered from databases, from clicks, from web pages, whatever, or the data that has been generated by AI engines. I hope I wish I answered your questions.
Is that answering your question, Isas?
Yes, it was very eye-opening. Thank you.
You're welcome.
Thank you so much. This is the last question. It's come from Naila. Naila, are you there?
Yes, ma'am. Can you hear me correctly?
Yes, I'm hearing
it's
you.
clear.
Okay, thank you so much, first of all, for Dr. Maher for your insightful lecture. My name is Naila, and I have a question about the practical aspects of your data science workflow. So, in your experience, how do you typically allocate your time across the different phases of the data science workflow? I'm curious if there's any common patterns or if it varies significantly depending on your project type. And how does that change when your exploratory analysis or your first phases reveals that your initial approach needs significant revisions or change? Thank you.
Thank you, Nila, for your effective questions. It's very important questions. How can, based on my experience using different framework, rather than the one that has been used or discussed in previous slides, actually, as I have mentioned, it was like 5 stages of the frameworks for myself. Based on my experience, I'm following the same framework. Before I begin the first stage of data collections, I ask myself first, do I relying on reliable data source before the data collection begins? Okay, if I am confident that I am relying on the first on the data source, okay, collect that data, prepare it, clean it, explore it, then move to the next stage, either testing the model, then prepare it for the last stage, data visualization, or do I need to go back to first stage? So the way I'm working with the framework, I'm using the word of the framework, this is my strategy. First of all, identify either I am relying on reliable data sources I'm collecting, gathering data from, then adding or aligning with the 5 stages that has been mentioned earlier, which is data processing, cleaning, analyzing, visualizing, then testing this model. I hope I have answered your questions.
Yes, you actually have. Thank you so much.
You're welcome.
Okay, thank you so much. I believe there is still enormous questions that we want to discuss. However, due to a limited time, so we need to end up our discussion session. There is one message from our head of department. Since there are also many lecturers in information systems who research is related to data, including me, we really hope to be able to collaborate on research or joint publications in the future with Dr. Maher.
Sure.
Right.
And I would like to mention the first very important point, which is uh, based on discussion with the top management here at the Najran University, the deanship here and top management, when I show them the presentation that I am going, the lecture I'm going to share, and they are warmly welcoming any partnership with the universities worldwide, especially with the university, or either in Malaysia or in Indonesia, and they are welcoming the partnership, and they have also external sponsorship for international students from Malaysia or from Indonesia. For further information, please navigate to Najran University website and navigate to international students. You will see huge informations and important informations if you would like to study overseas, or any of your friends would like to study overseas in Najran University. They are welcoming and partnership. From this point, I am like I will organize with Dr. Tony with the partnership or sign the contract or with the partnership with the Najran University, especially Applied College with your institute, and it will be honored with us to collaborate with you.
Yeah, thank you. So we also encourage for further collaboration with you. All right, so we finally come to the end of this guest lecture. Before I close these sessions, I have one favorite quote that Dr. Maher put in his slides. Every great analysis start with the right questions. So be careful not to jump into the analysis tools before fully understanding what the problem leads.
Yes, of course.
Finally, I would like to thank the speaker, Dr. Maher, for the informative and interesting presentations. Also, all of the participants for their active participations. Hopefully, this lecture will be beneficial for everybody. Amen. Please give applause for the speaker, Dr. Maher, and for you all. Thank you, everyone. I hope you enjoy your rest of the weekend. Wassalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh. Thank you. Thank you, Dr. Maher.
You're welcome and willing to see